Ancient Greece, Perecydes of Syros. Earthquake forecasting is one of the most ancient skills known to mankind. The first known forecast was made by Perecydes of Syros about 2,500 years ago. He predicted a strong earthquake by noticing that clean well water suddenly became dirty and salty. The earthquake occurred 2 days later, bringing fame to Perecydes. Following his success, another philosopher, Theopompus of Chios, proposed using wells as observatories to forecast earthquakes. In 373 BC, a devastating earthquake destroyed the ancient Greek city of Helike. It was one of the first earthquakes well described by famous Greek philosophers Aristotle, Diodorus Siculus, Pausanias, and Claudius Aelian. They wrote about earthquake precursors leading up to the event, including unusual lights in the sky, atypical weather patterns, and changes in animal behavior. Notably, many animals left the city 5 days before the earthquake occurred. Ancient China, the first seismoscope. In 132 CE, Zhang Heng created the first seismoscope to detect the direction of earthquakes. It was an ornate bronze urn with 8 dragon heads, each facing a compass direction. When an earthquake occurred, the pendulum inside caused one of the dragons to release a ball, indicating the earthquake's direction and location. Medieval Italy, first theories. A few theories of earthquake origin were developed in medieval times. In the 16th century, Italian scholar Girolamo Cardano proposed that tremors were caused by the movement of gases in the earth, one of the early theories to explain earthquake phenomena. The Great Lisbon Earthquake and Seismology origin. Seismology, as a branch of science, was founded in 1755 after the Great Lisbon Earthquake in Portugal. This earthquake caused significant loss of life and destruction, which prompted the scientific community to pursue the truth about earthquakes to prevent similar disasters from happening again. Japan, the first seismometer. The first modern seismometer was developed in the late 19th century. In 1880, John Milne, James Alfred Ewing, and Thomas Gray, all working in Japan, created the first horizontal pendulum seismograph. After the devastating Great Japanese Mino-Owari earthquake in 1894, countries like Japan established seismology organizations to understand earthquakes better and develop measures to mitigate their effects. Earth's core discovery, United States. In 1906, Richard Dixon Oldham, analyzing earthquake waves, discovered that the Earth has a core. Elastic rebound theory, United States. In 1910, following the 1906 San Francisco earthquake, Harry Fielding Reid introduced the elastic rebound theory. This theory describes how energy is released during earthquakes, fundamentally changing the understanding of seismic events. Prediction of the 1923 Great Kanto earthquake, Japan. In 1923, a devastating earthquake and tsunami occurred near Tokyo, resulting in the deaths of approximately 142,000 people. Seismologist Kei Imamuri had predicted the earthquake a year earlier, based on observed seismic quiescence, but his warning was ignored. After the event, Japanese seismologists started to take Imamuri's ideas seriously. They predicted a large Kanto earthquake between 1960 to 1965, but it turned out to be a false alarm, and undermined Imamuri's model. The Richter scale, United States. In 1935, Charles F. Richter developed the Richter magnitude scale, which quantified the scale of earthquakes. Although now largely replaced by the moment magnitude scale, this scale was a critical tool for assessing earthquake intensity. Plate tectonics theory. The development of the plate tectonics theory in the mid-20th century revolutionized seismology. This theory explained the occurrence of earthquakes at plate boundaries, providing a comprehensive framework for understanding geological processes. In the 1950s, the Chinese government established a ministry to forecast earthquakes, and Chinese seismologists successfully predicted a M7. 3 Haicheng earthquake in 1975, saving around 200,000 lives through successful evacuation. However, they failed to predict the next big earthquake in Tangshan near Beijing, which destroyed the city and killed nearly 250,000 people. The Global Seismographic Network was established in 1986. It is a collaborative project between the US Geological Survey, the National Science Foundation, and the Incorporated Research Institutions for Seismology. The network has allowed for real-time monitoring of earthquakes worldwide, providing critical data for scientific research and practical applications in disaster response. Parkfield Experiment, California. The Parkfield Experiment was an ambitious earthquake prediction project focused on the San Andreas Fault near the small town of Parkfield. This site was chosen due to its history of moderate earthquakes occurring approximately every 22 years since 1857. Initiated in 1985 by the US Geological Survey, the experiment aimed to predict and capture a significant earthquake by 1993. Based on the regularity of past quakes and backed by a 95% confidence level prediction. However, the expected earthquake did not occur within the predicted time frame. After the well-prepared Parkfield experiment failed, it was concluded that earthquake forecasting is impossible, and funding for such research was stopped worldwide. Seismic risk maps. By the late 20th century, seismologists began creating detailed seismic hazard maps that predicted the geographical distribution of earthquakes. These maps helped in urban planning and the construction of earthquake-resistant structures. Finally, in 2012, Terra Seismic, the first global earthquake prediction company, was established. Since 2019, the company has been based in Basel, Switzerland. Our global earthquake prediction is based on determinations of the stressed areas that will behave abnormally before major earthquakes. The company applies various methodologies to identify abnormalities and make predictions, including satellite remote sensing methods and data from ground-based instruments. We develop long-term, 3 to 5 years, mid-term, 1 to 3 years, and short-term, 1 to 12 months global prediction systems. What sets Terra Seismic apart from previous attempts? Firstly, we have gathered knowledge on earthquakes, their precursors, and earthquake forecasting methods from all available sources over the past 2,500 years. Our science team has over 30 years of experience in this field. We utilize innovative satellite big data technology to analyze terabytes of information daily. Unlike many scientists who focus on specific regions, big data allows us to analyze data from around the world in almost real time efficiently. We are open-minded and develop new theories and models. Lastly, we are independent from outdated beliefs, which allows us to approach the problem with fresh perspectives and make significant discoveries. In practice, Terra Seismic global earthquake prediction is very similar to a doctor's diagnosis of a patient with a medical problem, kidney disease, for example, by collecting multiple analyses without surgery. In our case, the whole world serves as the examined patient, just as disease is a deviation from normalcy in the human body because something is wrong. Abnormalities in geophysical parameters indicate that something is wrong in this part of the world. Before a strong or major earthquake, we notice anomalies in the data we collect, which signal that a strong event is approaching.
City lights, they shine so brightly when I'm coming home to you. Every night when I'm driving home, all I think about is you. Won't be long until I see your smile, like the sun you shine.